Hey guys, welcome to section 1, chapter 3 of the geometry program. In this chapter, we're going to start our introduction to parallel lines. So as has been the case for us, we have a bunch of definitions. So take your time writing these out, then we're going to draw corresponding pictures with each of them. You probably know this, but in the event that you don't, parallel lines are two lines that never cross and have the same slope. So we would look at parallel lines as lines that look like this. They never cross, have the same slope. We could run them like this. We could really do them in any direction we wanted, as long as they were going up at the same speed and never cross. Okay, also to note, these two little flags are the indication that the lines are parallel. On some of your texts, you might actually see them just written in a single flag like this, but it's in a different color. This is more unusual. This is the typical to see the two flag notation. When you see that, then we know that the lines are parallel. So we're going to be looking for that in order to apply the theorems. Okay? All right, transversal, that's a big word, but it simply means the line that's going to cross through two coplanar lines. Now, the coplanar lines don't necessarily have to be parallel. So this is the transversal. It's the line that cuts through, all right? The line that cuts through. Okay. All right. Now, here are three big ones. Alternate interior angles. So let's say we have a set of parallel lines that are cut by a transversal. All right. So these guys are parallel. We know that because of the flags. The transversal cuts through. Alternate interior angles are going to be angles that are on the inside of the parallel lines and on opposite sides of the transversal. For example, 1 and 2. There's another set of alternate interior angles here, 3 and 4. All right, there's something else that we know about alternate interior angles. Alternate interior angles are congruent. So the measure of angle 1 is congruent to the measure of angle 2. And the measure of angle 3 is congruent to the measure of angle 4. So they are congruent angles. This is important because that means when we're solving for them, if you have one alternate interior angle and the other with an unknown, we can just set them equal to each other. And we're going to practice that in a bit. Okay, next one, same side interior angles. All right, so let's say you have a set of parallel lines that are cut by a transversal. Parallel. Transversal. Transversal. All right, same side interior angles are two angles that are both on the inside of the parallel lines and on the same side of the transversal. For example, 1 and 2. They're on the inside of the parallel lines and on the same side of the transversal. There's another set of same side interior, 3 and 4. Now, hopefully your eyes are telling you that these angles do not look congruent because they're not. However, we do know that the measure of angle 1 plus the measure of angle 2 are going to equal 180. So same side interior angles are supplementary. and angle 3 plus 4 is equal to 180. Okay, so that's helpful. All right, let's do one more here, and that is corresponding angles. Corresponding angles are on the same side of the transversal, but one is on the inside of the parallel lines and one's on the outside. So let me just show you over here. Okay, so for example, 1 and 2, or 3 and 4. And corresponding angles are also congruent. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. They are congruent angles. Okay, so our task is to be able to identify the angles that we have, and then we're going to try to solve for them, I should say. Okay, so for example, in this drawing, if you just look at angle 1 and angle 2, we want to decide what type of angles these are. And our options are alternate interior. Alternate, you're going to see I'm going to use a lot of abbreviations. Alternate interior, same side interior, or corresponding. All right, those are the options. All right, so if you notice here, the parallel lines are denoted here, meaning this is our transversal. And 1 and 2 are on the inside of these parallel lines and on opposite sides of the transversal, making them alternate interior. So angle 1 and angle 2 are alternate interior angles. All right, take a look at angles 3 and 4. These guys are on the same side of the transversal, right? They're both on this side of the transversal. And one's on the inside of the parallel lines. One's on the outside of the parallel lines. That makes them corresponding angles. All right. Now let's look for angles 3 and 2. I'm going to trick you. Angles 3 and 2 are both on the inside of the parallel lines and on the same side of the transversal. So 2 and 3 would be same side interior. But also 1 and 5 would be same side interior. We can actually list several of these as we go through. Okay, so once you feel comfortable being able to name what the relationship is, then we get to apply our knowledge. So believe it or not, in a picture like this, if you know just 1 degree measure, that is right here, 70 degrees, we can actually find the measure of all of the other angles because of these relationships and because of what we learned previously. So if you look at this 70 degree angle and angle 2, you would notice that they are vertical angles. We were practicing this last time. And vertical angles are congruent. So we know that angle 2 is congruent to 70, meaning its measure is 70. So I'm going to make a list here. So the measure of angle 2 is 70 degrees. Okay, then we also learned last time about linear pairs or angles that are supplementary. Sorry, I erased my 70 there. And if you notice, 70 and angle 1 form a linear pair. So that means that angle 1 plus 70 has to equal 180. So if we do a quick little math, the measure of angle 1 has to be 110. All right, so this guy is 70. This guy is 110. So guess what the measure of angle 4 is? The measure of angle 4 has to be the same as 1 because they're vertical angles. So the measure of angle 4 is also 110. All right, that wasn't too bad. That was applying information from last section. But now we have to jump to this next part. So how do we know 5, 6, 7, and 8? Well, now we're going to apply these 3 principles that we just learned. So you can grab any one you want. I kind of like alternate interior. I'm kind of privy to that. So if you notice, 70 degrees and angle 6 are alternate interior angles. Alternate interior angles are congruent, meaning angle 6 is 70 degrees. Also, angle 4 and angle 5 are alternate interior angles, also congruent. So the measure of angle 5 has to be 110 degrees. And then we can build the same way we did the other set of angles. 6 and 8 are linear angles or supplementary angles. So the measure of angle 8 also needs to be 110. And 5 and 7 are linear angles, meaning 7 has to be 70 degrees. If that was too fast, make sure you go back, slow down, and go through it again. I want to jump to this one and not make the video too long. Okay, so then now we have to apply our information about angles and solve for x. So notice this angle and this angle are corresponding angles. Corresponding angles are congruent angles. So we can set them equal to each other to solve for x. And then solve for the measure of the angle if we need to. So if we subtract x and we add 5, x equals 30. And then if we needed the angle measure, we could plug that in. 30 times 3 is 90 minus 5, so this has to be 85 degrees. And over here, the same thing, 30 plus 55 has to be 85 degrees. All right, what if we wanted to do this last guy? This angle and this angle are alternate interior angles. So they are congruent. We can set them equal to each other. If you subtract 19y here and add 5, we know y equals 5. Make sure that as you go through, you are paying attention to the relationship of the angles and whether they're asking you to solve for the angle measure. So finish up your notes, read through the examples, and begin your assignment.